So in this video, we're going to talk about how to multiply polynomials. So remember, a polynomial is a monomial or the sum or difference of two or more monomials. Remember that binomials and trinomials are types of polynomials. So remember, we also have this product of powers that we talked about in the exponents review video. If we multiply together two terms with the same base, we're going to go ahead and add the exponents. So remember, when we're working on these kind of problems, the coefficients and variables will follow different rules. So you want to think about the coefficients separately from the variables, because the coefficients will follow the standard rules of multiplication, division, whatever you're doing in the problem, but the exponents will follow the special exponent rules. So we're going to use the distributive property, which we did talk about when we were multiplying binomials, because some of you chose to use distributive property instead of using FOIL. So FOIL is something that applies only to binomials. So when we're doing polynomials, we actually have to all use the distributive property. So what we do is we take each term of the first, in this case, binomial, and we distribute it to the second binomial. So we're going to do x times x plus 5 plus 4 times x plus 5. So we basically break apart this first binomial. So similarly, if we're multiplying by a trinomial, we're going to take this x and then just multiply by all the terms in the trinomial, and then add it to 4 times all the terms in the trinomial. So here are the steps. We're going to start off by distributing each term in the first polynomial to the second polynomial. Remember to distribute the sign in front of the term along with it. It can be helpful to rewrite subtraction as addition of the opposite. Multiply and remember to use the product rule for terms with exponents, and then combine any like terms to simplify the final expression. So let's try multiplying x plus 4 times x squared plus 5x plus 3. So we're going to distribute each term in the first binomial to the second trinomial. So we have x squared plus 5x plus 3 plus 4 times x squared plus 5x plus 3. So now we're going to distribute x. So x times x squared is going to give me x cubed, plus x times 5x is going to give me 5x squared. X times 3 will give me plus 3x. And now we're going to add it. We have 4 times x squared, which is 4x squared, plus 4 times 5x, which is 20x, plus 4 times 3, which is 12. So now what I want to do is go through and find like terms that I can combine to simplify my final expression. So I start off with my x cubed. Then I have 5x squared, and I'm going to go through and look for any other x squared terms. Well, I have this plus 4x squared, so I'm going to go ahead and write that along with it. And then now I have this plus 3x, and I can combine that with this plus 20x. And now finally we have this plus 12. So let's go ahead now and simplify. So we have x cubed plus, then we have 5x squared plus 4x squared. So that's going to be 9x squared plus 3x plus 20x. So that's plus 23x. Plus we have the constant term, which is 12. So now we have the fully simplified expression. So let's go ahead now and multiply 2x minus 1 times 3x squared plus 4x minus 5. So I'm going to take every term in the first and distribute it to the second polynomial. So now let's do minus 1 times 3x squared plus 4x minus 5. So I'm going to distribute 2x. So 2x times 3x gives me 6x cubed, plus 2x times 4x gives me 8x squared, and then 2x and then times 5, so we have minus 10x. So when I do that -1, I'm going to think about that as like a plus -1. Okay, so that way I'm distributing it correctly to all of these terms. So -1 times 3x squared is going to give me minus 3x squared. -1 times plus 4x is going to give me minus 4x. And then -1 times minus 5 is going to give me plus 5. Now I'm going to go through and combine my like terms. So I have this 6x cubed, and then I'm going to add it to 8x squared. 8x squared will combine with minus 3x squared. And then I have minus 10x, which combines with minus 4x. And then I have plus 5. So now let's go ahead and combine these like terms. So we have 6x cubed that doesn't combine with anything. And then 8x squared minus 3x squared is going to become plus 5x squared. And then I have minus 10x minus 4x will become minus 14x. And finally, we have this plus 5. So here is the simplified version of the final answer. So now you can go ahead and pause the video and try doing this example on your own. So I'm going to take that x and distribute it to the second trinomial, and then I'm going to add it to 3 distributed to the trinomial. So I have 2x cubed minus 5x squared plus 8x, and then distributing 3 gives me 6x squared minus 15x plus 24. And then I'm going to go through and reorganize this so that my like terms are together. So I have 2x cubed minus 5x squared plus 6x squared, 8x minus 15x, and then plus 24. So I'm going to simplify this by combining like terms. So once again, 2x cubed stays alone. Minus 5 plus 6 gives me 1. So I don't write those coefficients of 1, so I just have x squared. 8 minus 15 gives me minus 7x, and then plus 24. So now let's try this problem. So here you can see it's a little bit different because we have 2 trinomials. But, you know, it doesn't matter how many terms we have. We just keep repeating the same process. So here what I'm going to do is I'm going to take each term in the first. So I have x squared. And then I'm going to multiply by the second trinomial. So times 2x squared minus x plus 1. Okay. Now I do the second term. So I do minus 2x times 2x squared minus x plus 1. Okay. And then I have plus 5 times 2x squared minus x plus 1. Okay, so you see it's the same process as before. It's just a little bit longer because we have more terms. So I do x squared times 2x squared. So I have 2x to the 4th. And then minus x squared times x. So that's going to be x cubed. Plus x squared times 1, which is just x squared. Okay, so that minus 2x, I'm going to distribute that as like a negative 2. So I'm going to rewrite this as plus negative 2x. And so I'm going to distribute that. So that's going to give me minus 4x cubed. Okay, my negative 2x and then minus x, that negative and the minus are going to make a plus. So I have 2x squared. And then I have my next distribution, negative 2x times plus 1 will give me minus 2x. Now for the last set. So I do 5 times 2x squared, which is plus 10x squared. And then minus 5 times x, which is 5x. And then plus 5 times 1, which is just 5. Now let's go through and collect all of our like terms. So there's no other x to the 4th term, so I'm just going to write 2x to the 4th. And then I have minus x cubed, minus 4x cubed, and let's see, no other x cubed terms. Okay, so now we have plus x squared, plus 2x squared, and then plus 10x squared. Okay, so now for our x term, so we have minus 2x, minus 5x, and then finally plus 5. So now let's go ahead and simplify this. So the 2x to the 4th is just going to stay alone. Okay, minus x cubed, that's a minus 1 basically. And then so we have minus 1 minus 4, so minus 5x cubed. Plus x squared is just like a 1x squared. So 1 plus 2 plus 10. Well, 1 plus 2 is 3. 3 plus 10 is going to be 13x squared. And then we have minus 2 minus 5, so that's minus 7x. And then finally we have plus 5. So 2x to the 4th minus 5x cubed plus 13x squared minus 7x plus 5 is our final answer. So now let's try just another one just to make sure we've got this. Like I said, it doesn't matter how many terms we have. We just keep repeating this process, right? So I'm going to do x squared times 3x cubed plus x squared minus 7. And then we do minus 4x times 3x cubed plus x squared minus 7. And then plus 1 times 3x cubed plus x squared minus 7. Okay, so let's do all our distributing. So we have x squared times 3x cubed, so it's going to be 3 and then x to the 5th. X squared times x squared is going to be plus x to the 4th minus x squared times 7, so that's 7x squared. Okay, so that minus 4x, I'm going to rewrite that as plus negative. So we're going to distribute negative 4x times 3x cubed. So negative 4 times 3 gives me minus 12. X times x cubed is going to give me x to the fourth. So negative 4x times x squared is going to be minus 4x cubed. And then we have negative 4 times minus 7, so that's going to become plus 28. And then we have x. Okay, so the nice thing about the last set we have to distribute is it's times 1. So all of these terms are going to stay exactly the same. So we just have plus 3x cubed plus x squared minus 7. Now let's go through and collect all our like terms. So we have 3x to the fifth, and there's no other x to the fifth terms. Okay, we have plus x to the fourth, and we have minus 12x to the fourth. So now let's look at our x cubed terms. Okay, we have minus 4x cubed plus 3x cubed. And now we have minus 7x squared plus x squared. And then plus 28x, and then minus 7. Okay, so 3x to the fifth has no like terms, so we're going to leave it alone. X to the fourth, remember that's a 1x to the fourth. So 1x to the fourth minus 12x to the fourth will be minus 11x to the fourth. Minus 4x cubed plus 3x cubed is going to be minus x cubed, right? Because it's minus 1x cubed, so we don't have to write the 1. Minus 7x squared plus 1x squared is going to be minus 6x squared. And then plus, we have 28x, and then minus 7. Okay, so that is going to be our final answer. So now you can go ahead and pause the video and try doing this example on your own. So here, it's two trinomials, so same process as before, just a lot more multiplication and distribution to do, right? So we do x squared times the second trinomial, then x times the second trinomial, and then minus 4 times the second trinomial. So when we do that, remember we get all of these terms. The x to the fourth has no like terms, so we just leave that as 2x to the fourth. We combine all the cube terms, and so that gives us minus 3x cubed plus 2x cubed, which is minus x cubed. 5x squared minus 3x squared minus 8x squared gives us minus 6x squared. And then 5x plus 12x gives us 17x, and we have minus 20. Remember, you can multiply polynomials with any number of terms using the distributive property. Remember to combine like terms to simplify the final expression.